As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I am joining Shobhit University. What about you?
We welcome all the participants from India and abroad to this international webinar series today. Shobhit Institute of Engineering and Technology Meerut, deemed to be university and its centers of excellence, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications, in association with African Asian Rural Development Organization, ARDO, New Delhi, organized this weekly international webinar series on open source digital technologies towards a self-reliant India, Atmanirbhar Bharat. Today is 5th June 2021, World Environment Day. Our tribute to our environmentalists today. One health, eco health is very important. On behalf of the Chancellor, Honorable Chancellor, His Excellency, the Secretary General ARDO, Honorable Vice Chancellor, the faculty members of the university, and on my behalf, and as Professor Emeritus and Chairman of Center of Excellences, Center for Agricultural Informatics and E-Governance Research Studies, Center for Agri-Business and Disaster Management Studies, Center for Informatics Development Solutions and Applications, and Center for Agri-Business and Disaster Management Studies, and Center for Industry 4.0 Technology Studies and Applications. Let me welcome our guest speakers of today's webinar, Dr. Rajkumar SATANKAR. Good morning. He is an associate professor, mechanical engineering, Poornima College of Engineering, Jaipur, state of Rajasthan. For your information, under this international webinar series, these two centers of excellence, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications, have organized 30 lectures so far during this COVID-19 pandemic period. Open technologies to provision simple and economical IT infrastructure, a roadmap for students using free and open source software, and reaching goals of Atmanirbhar Bharat. Open source software and industrial IoTs for SMEs. Free and open source software adoption oblique business models. Open data platform for smart digital government. Technology imperatives make in India for self-reliance. Edge artificial intelligence. Data governance for self-reliant India. Digital India transforming governance and society. India's email service, citizens@indiamail.com in 22 constitutionally recognized languages. Ecosystem architecture for digital transformation. Education system, cyber critical infrastructure. Seizing opportunities in open innovation and value creation network in the digital world for self-reliant economy. Ensuring food safety and compliance through technology. Digital India, urgent need for semiconductor manufacturing in India. Technology investment in agriculture, agriculture value chain, role of foreign direct investments, entrepreneurship and skill development. artificial intelligence designed pathways, the rise of platform economy, revisiting value chain governance, the era of automation, industrial robotics, and Industry 4.0, Indo-German perspectives of technology transfer, skill gap analysis, and opportunities. Role of artificial intelligence in healthcare, current developments in diagnosis and vaccine research, digital agri-tech and agri-startup perspective, health informatics value chain, e-health systems and beyond, leveraging emerging technologies for ensuring transparent and traceable agri and food supply chain, unleash the power of citizen development for enterprises software development, e-governance models towards sustained quality service to serve citizens backed by technology. Indian MSMEs to adopt Industry 4.0 technology capabilities, urgent need for mentorship and accelerator program. Building public digital platform using microservices and APIs. Health informatics network value chain, early childhood development and learning. Health informatics network value chain, clinical artificial intelligence, interface between machine learning and health informatics. Health informatics network value chain, importance of social medicine and community health in the times of health emergency. Today is the 31st edition of this very important webinar series. We'll have the talk by our guest speaker, Dr. Rajkumar SATANKAR, Associate Professor Mechanical Engineering, Poornima Engineering College, Jaipur, on the topic, very important topic, which will facilitate community manufacturing enterprises. On the title, G-filter. G-filter means gravity filter, a simple, low-cost solution to the drinking water treatment in rural India. The title, once again, I will read it. G-filter. G-filter means gravity filter, a simple, low-cost solution to the drinking water treatment in rural India. The keywords are, associated keywords are drinking water treatment, rural India, low-cost solution, simple low-cost solution, community health, network value chain, health informatics, and community-based manufacturing. To recall, on 29th May 2021, Professor Sankar Mitra Sheel Acharya, Center for Social Medicine and Community Health, School of Social Sciences, Jawaharlal Nehru University, New Delhi, addressed this webinar series on the topic Health Informatics Network Value Chain, Importance of Social Medicine and Community Health in the times of health emergency. Within 1 week, there are about 35 views of this YouTube link. That is the interest which has generated in the digital world on community health and social medicine, and also health informatics network value chain. Before this talk, on 5th December 2020, Dr. Jabamale Vinanchi Arachi, former principal advisor to the Director General, United Nations Industry and Development Organization, UNIDO, Vienna, Austria, addressed the webinar series on the topic Seizing Opportunities in Open Innovation and Value Creation Network in the Digital World of Self-Reliant Economy. I talked about the keywords Key Health Informatics Value Chain, which has the components as shown, as detailed: public health system, plant health system, animal health systems, fish health systems, soil health systems, water quality systems, and air quality systems. Water is the basic component, and good water, good quality water is very important. And in rural India, this is a big problem. And the lot of digital technologies in healthcare are also being talked about it. And on this one, very important technology, a component of Industry 4.0, which can facilitate community-based manufacturing of today's topic, the component, the G filter, can be facilitated through the technology component of 3D printing over internet to the pottery community who can, get trained on 3D printing of the Industry 4.0 technology, and they can bring out this component to solve drinking water problem, drinking water quality in the rural India. That's why I said it that it will facilitate community-based manufacturing enterprises, CME. Atmanirbhar Bharat is the road ahead for us in India. This is the vision of our Honorable Prime Minister of India, Shri Narendra Modi, of making India a self-reliant nation rested on 5 I's: intent, inclusion, investment, infrastructure, and innovation, based on 5 pillars: economy, quantum jump; infrastructure, one that represents modern India; system, 21st century technology driven; vibrant demography, sources of energy for self-reliant India; and demand, whereby the strength of our demand and supply chain should be fully utilized to full capacity. It was announced on 15th May 2020 by the Central Government more than 1 year ago. Vocal for local to make it global. A demand-based economy system which is self-producing, self-consuming. Make in India, make for India, and make for global. The reforms announced have been systematic, planned, integrated, interconnected, and futuristic for creating strong enterprises, generating employment, and robust supply chain. This is our India. Now let me give some information related to drinking water treatment in rural India. This will facilitate the participants to this international webinar series to understand and appreciate the address by Dr. Rajkumar SATANKAR. Drinking water quality standards describes the quality parameters set for drinking water. Despite the truth that every human on this planet needs drinking water to survive, and that water may contain many harmful constituents, there are no universally recognized and accepted international standards for drinking water. This is as per the statement put it in wikipedia.org. Despite the truth that every human on this planet needs drinking water to survive, and that water may contain many harmful constituents, there are no universally recognized and accepted international standards for drinking water. IS 10,500 2012 as amended in 2015 of Bureau of Indian Standards, Government of India provides drinking water specification. Safe access to potable water in household premises will not only improve the health of rural people by reducing spread of waterborne diseases, it will also provide economic opportunities in rural India, especially for women, by freeing up the time otherwise spent in fetching clean drinking water from long distances. The World Health Organization, WHO, prescribes 25 liters of water for one person per day to meet all basic hygiene and food needs. Water quality parameters include chemical, physical, and biological properties and can be tested or monitored based on the desired water parameters of concern. Parameters that are frequently sampled and monitored for water quality include temperature, dissolved oxygen, pH, conductivity, oxidation reduction potential, ORP, and turbidity. Waterborne diseases and their impact, pathogenic microorganisms, their toxic exudates, and other contaminants together cause serious conditions such as cholera, diarrhea, typhoid, amoebiasis, hepatitis, gastroenteritis, giardiasis, scabies, and bone infections, etc., to name a few. E. coli bacteria found in the digestive tract of animals can get into the environment and, if contacted by people, can cause health problems and sickness. Drinking water mission of Government of India, called Jal Jeevan Mission, is envisioned to provide safe and adequate drinking water through individual household tap connections by 2024 to all households in rural India. Will implement source sustainability measures as mandatory elements such as recharge and reuse through grey water management. Will be used on a community approach to water. Will include extensive information, education, and communications as a key component of the mission. Looks to create a Jan Andolan for water, thereby making it everyone's priority. Total rural households as on 3rd June 2021 are 19 crore 19 lakhs 63,738. Rural household tap connections provided till 3rd June 2021 according to the website of Government of India are 7 crore 47 lakhs 37,364. It means 38.93% of the rural households have got tap water connections. In his Independence Day speech in 2019, our Honorable Prime Minister Shri Narendra Modi said that half of the country's household did not have access to piped water, earmarking rupees 3.5 trillion budget for Jal Jeevan Mission. Jal Jeevan Mission. He said the center and states would work towards it in coming years. Vocal for local for making it global. Community-based entrepreneurship model. Community-based entrepreneurship is considered to be a very important instrument for the realization of potential among marginal and deprived communities isolated from the mainstream economy, and is important in bringing social upliftment, cultural values, shared resources, linkages, and mutual trust work for the community, nurtured through close personal relationships for the functioning of economic activities. Entrepreneurial activities creating local public goods for a community have a comparative advantage over the absolute market-oriented activities. This is from an article written by Mr. Parvesh, in the Journal of Innovative Entrepreneurship. Commons-based peer production is a term coined by Harvard Law School professor Yoshi Benkler. It describes a model of socio-economic production in which large number of people work cooperatively, usually over the internet. Commons-based projects generally have less rigid hierarchical structures than those under more traditional business models. Creating a circular economy requires an industrial scale response, but this can be complemented by a community-based response and associated physical infrastructure, such as makers space, fab labs, community technology workshops, and any other community-based form that falls under the umbrella of shared fabrication spaces. Vocal for local, making it local of Shri Narendra Modi, our Honorable Prime Minister, is making the room for community-based circular economy. Let us come back to gravity filter, research and development, the background material as available from the publications of today's guest speaker, Dr. Rajkumar Satankar. He quotes very important two aspects of rural Rajasthan. In rural houses of various parts of India, animal dung finds its regular use as an additive to mud or clay in floor finishing and wall construction. Marwar region of Rajasthan state in India defines an ecological habitat for its Icus breeds. That is the reason of abundant availability of horse dung in this region, and thus still finds its use in the construction of load-bearing material to construct a wall in rural homes. The study and experimental results on the thesis report of Dr. Rajkumar Satankar that horse dung composite strength properties are at par or better than concrete with a comparatively faster curing rate. The construction method uses an equal volume of horse dung and pond soil, Meth Miti in Marwadi dialect. This technology basically is inherited by Marwadi women, Santi or Sansi, who construct aesthetic indoor shelves. Structural integrity is an embedded technological advantage in mixture composites containing equal volumes of soil and organic materials. The study also acknowledges these composite constructions to provide an environmental conditioning, including prevention of microbial growth within the closed spaces. I'm very happy that we are having this address on the day in the World Environment Day. Off-white cress or earthen parts, a mix of soil and organic material such as sawdust. Another material of sustained importance in this region is the off-white cress or earthen parts. The baked ceramic off-white color crust is manufactured from a mix of soil and organic materials such as sawdust. Off-white water cress has prescriptive acceptance in this region through ages compared to red-colored water cress from the neighboring state. Better resistance to load and cooling capacity were found to be the technological advantages responsible for age-old sustenance of these parts. The off-white color of crust of Western Rajasthan is due to the presence of the salt. Apart from these technical aspects, cultural reasoning, that's ethnographic, has also reported sustenance of using an off-white colored pot for drinking water. It also reiterates that the use of these pots in different cultural events around the year by societies helps to preserve and sustain the technological innovation. Mixing of sawdust and clay soil for manufacturing clay ceramic water filters in several parts of the globe. Dr. Rajkumar Satankar have looked into various queries related to this aspect, and in his thesis he traces the basic manufacturing management practices of composites used in pottery practices of local rustic Western Rajasthan in order to investigate possibilities of such a connection. Baking strategies within the local potter's traditional knowledge. Baking strategies within the local potter's traditional knowledge, which can be utilized to manufacture ceramics with structural quality, microstructural functionality at par with the international procedures, and efficiency to treat water to drinking water capabilities, and efficiency to treat water to drinking water qualities. Thus, this document provides scientific explanation. This address provides scientific explanation to traditional technologies for production of soil-based functional material, shows the harmonization between new techniques and sustained traditional manufacturing technology. New techniques and sustained traditional manufacturing methodologies. Dr. Rajkumar Satankar provides empirical and theoretical explanations for the hidden engineering within systems and devices which made them sustainable. With this background, let us now turn to the address of Dr. Rajkumar Satankar on the topic G-filter, a simple, low-cost solution to the drinking water treatment in rural India. In this talk, as per the synopsis of the guest speaker, we will come to know that the G-filter is a simple, low-cost, physical treatment-based household water treatment system that work on gravity and also ensures zero water waste during filtration, zero water wastage during filtration. It is capable of removing drinking water pathogens and turbidity. E. coli removal of 99.99% is observed after testing the filtrates from a filter with a contaminated inflow. These filters can be produced with a regular pottery setup using locally made available soil and sawdust, which can contribute to the growth and maintenance of local pottery community. Traditional packing knowledge of the water community for packing a flour base is incorporated to get quality output and saving electrical energy in packing. Local material use and traditional method of manufacturing and low cost Indian rupee 350 to 500 makes G-filter as a prominent solution to the problem of drinking water treatment in India. This topic will motivate and galvanize the participants watching over telecast through facebook.com Sobit University India or youtube.com Sobit University in for motivating them to establish tech startup with Industry 4.0 technology, 3D printing, with locally available material, soil and sawdust, in collaboration with the local potters community in rural India. Industry 4.0 technology, 3D printing. This will promote community-based entrepreneurs model of development, vocal for local, Atmanirbhar Bharat. Let me introduce our guest speaker. Let me read his profile. Dr. Rajkumar Satankar, he did his PhD from Indian Institute of Technology, Jodhpur. He is an associate professor of mechanical engineering, Poornima College of Engineering, Jaipur, state of Rajasthan, India. He was born in village Kirkia in Harda district, state of Madhya Pradesh in 1983. He received his diploma and BE in mechanical engineering from Rajiv Gandhi Pratyogiki Vishwavidyalaya, Bhopal, Madhya Pradesh. Further, he received his Masters of Technology in Mechanical Engineering from Sardar Vallabhbhai National Institute of Technology, Surat, Gandhi, Gujarat in the year 2009. In his professional career, Dr. Rajkumar Satankar has been associated with a reputed organization including SR Steel Limited, Surat, and ABG Shipyard Limited, Bharuch in Gujarat, Lovely Professional University, Jalandhar, Punjab, Gujarat Power Engineering and Research Institute, Mehsana, Gujarat, and JECREC, University, Jaipur, Rajasthan. Dr. Raj received his PhD from the Department of Mechanical Engineering, Indian Institute of Technology, Jodhpur, and he contributed a remarkable research in the field of research rural technology and developed various products for local Rajasthani clay and other organic waste found in Western Rajasthan. the use of rural populations in India. He has published about 15 research articles, including 6 journal papers, 7 conference papers, and 2 book chapters established and a patent filed in his name. His clay ceramic water filter, G-filter, technology for which he has filed a patent in India has been highlighted in various prints and electronic media worldwide. This technology not only provides job opportunities to the people of water community, but also ensures low cost, safe, and clean drinking water to rural populations in Indian villages. His work for the society has been recognized by various national and international NGOs and government agencies, including Enactus, IIT Madras, Segal Foundation, New Delhi, Potters for Peace, USA, and Water Harvest, UK. Being an excellent academician, researcher, and innovator, Dr. Kumar SATANKAR has been recipient of various awards and recognition, including some recent awards like Aryabhatta Samman from Swadeshi Science Movement NPL, New Delhi in 2018, Gyan Panch Samman from Bipin Joshi Samarak Samiti Hitachi, and Best Poster Award from Tech for Seva, Indian Institute of Technology, Delhi, 2019. His current research interests focus on composites, ceramics and water energy management, community-based manufacturing, and process management and probabilistic methods in engineering. Dr. Rajkumar Satankar, we invite you to address the international webinar series in open source digital technology for self-reliant India, Atmanirbhar Bharat, on the topic given by you, G-Filter, the simple, low-cost solution to the drinking water treatment in rural India. We welcome you. Over to you.
Good afternoon, sir. Thank you very much. Let me share my screen. Please allow me to share my screen, sir. Is the screen visible, sir?
Just it is. It's coming. No, it is not visible.
Just.
Is there any problem? Hello? Mr. Manish? Hello?
Yes, sir.
Is there any problem? Can Mr. Manish can present it?
Can you see the?
Okay.
It's showing, sir. It's showing.
Yeah. Yes, it has come.
Yes, sir. Thank you so much, sir. Good afternoon, everyone. Thank you, the Center for Informatics Development Solutions and Applications, CITSA, the Center for Industry 4.0 Technology Studies and Application, CITSA, at Soviet University for inviting me in their prestigious international webinar series supported by AARDO on open source digital technologies for self-reliant India to deliver me my talk on the topic G-Filter, a simple low-cost drinking water treatment solution for rural drinking water in India. And I'm thankful to entire community from Shobit University, especially Professor Moni, for guiding me towards this wonderful platform and introducing the topic and reading my introduction in a very great manner. And now, with his kind permission and consent, I would like to start my talk on the topic of the day: G-Filter, a simple, low-cost drinking water treatment solution for rural India. And at the beginning of this presentation, I would like to first take you toward Western Rajasthan, where the studies, experimentation, and development of this clay ceramic water G-Filter was carried out during my PhD program at IIT Jodhpur. As you can see in the map of Western Rajasthan, There are some pictures related to Western Rajasthan, and map is presented. And when you go towards it and you come over there in here in Western Rajasthan, you will find that it is an arid and adust landscape with the rural societies living in complete harmony with the prevailing ecological niche conditions and resources. There are examples where human beings are rearing animals such as horses, donkeys, camels, which are specific to this location. And due to high temperature prevailing this in the desert area of Western Rajasthan, people used to use clay pots to store and cool their drinking water for daily purpose, and they use these pots for regular water storage also before the advent of new amenities such as refrigerator. And that is how their people are making the livelihood of this livelihood sustainable for the people who make and use these devices. And at this point, you people will agree with me that it is not only the case of Western Rajasthan, at least almost all part of India or where there are rural societies, they have their own cultural processes, traditional practices based on their ancestral thoughts, ecological biodiversity there in their regions. And if they use some devices or doing some practices, there must be some functional aspect associated with that. And therefore, while studying all this, a question came in my mind, and I just would like to put this question towards you also, that are technological innovations embedded within the traditional devices, materials, and practices of daily use in rural India? As answer to this question, not only answers the sustenance of these devices even today in 21st century, but also answers that how these technologies, practices, materials of rural India can be the part of solution of modern world problem which we people have created in the name of progress, in the name of development. Today, on the eve of World Environment Day, we are speaking. So this topic is very relevant, that how sustainability can be achieved looking around, and how these people in the rural area manage their livelihood by just using the things that are available in the surrounding. And therefore, to address this particular talk, I would first like to discuss two case studies from my PhD thesis. And in those PhD thesis case studies, first I would like to briefly describe them and explain the prominent results out of these two case studies. And then I will just try to combine the result of these case studies and tell you that how the prominent results that we have got and the learning that we have received from these people of Western Rajasthan to develop a local low-cost drinking water treatment solution that is called as G-filter. So now starting with the case study one, that is from Western Rajasthan. It is based on the traditional construction practice by Santhi community women there. And Santi community women is basically a tribal community in this region, and in actual, they traditionally use equal volumetric ratio of horse dung and local soil to manufacture aesthetic cantilever structures on the walls to store the crockery items and utensils of their daily use. They have learned this technology from their ancestors, and as you can see on there is a map of India where I have shown the equine population distribution across the different states, and you can see that the abundant availability of Marwadi breed horses in Western Rajasthan might have given an idea to the ancestors of the Santhi community women to use horse dung as a construction material, citing the functional advantages from the locally available material to get strengthen their structure. And when I interacted with the very beautiful community people over there who are practicing this, they suggested that not only this material is responsible for providing a good strength to their structure, but also helpful to give an environmental conditioning effect to the structure, as well as their family. It keeps their family member away from various diseases, citing the medicinal properties of horse dung they stated. Therefore, when I visited to their places, I decided to find out and conduct a technical investigation on what the people were saying. And therefore, exactly in the way that people were practicing, I planned some experiment where the horse dung and clay samples, which is called as mate mitti in their dialect, were prepared and cured, and their different microstructural properties, strength properties, and other functional aspects have been technically verified, and results were plotted on different aspects. So now you can see one of the result of flexural strength according to the age of the various samples. The sample containing 50% volumetric ratio of horse dung and clay attains the maximum amount of strength at the age of 28 days while normal cooling is applied. You can see the diagram over here. I have just marked it with green. And in another image, which is a scanning electron microscopy image of horse dung, it shows the presence of calcium carbonate along with the cellulose fiber. Cellulose fiber are present because it is a natural material. All natural materials have cellulose fiber, but presence of CH3 crystals makes this horse dung as a good reinforcement material, and therefore it is capable to create a very strong network between matrix and reinforcement material. And another study carried out by one of the professor of Zurich University, they reported the presence of antibiotic named copsin in this horse dung, and therefore this study supports that the thought of Santi community women, where they cite the medicinal use of this horse dung and other material. Now, looking to this particular technical results and what Santi community women we may infer, we may just think out that what is the great amount of knowledge, what is the excellence knowledge those people have. In the year 2016-17, I have reported all this, while they have already, their ancestors have already learned, they have already have a thought process, and they have started using this horse dung as a construction material long back. Now, I am just moving towards the next topics, another material of sustenance in the community, Western Rajasthan community, and that is the off-white color water pots. Now you can see on the slide there are two types of the pot presented, red color pots and off-white color water pots. These red color water pots are basically supplied by the neighboring state potters of Gujarat, which is just on the border of Jodhpur district. And this off-white color water pots are manufactured by the local potters of potter community in Western Rajasthan using the locally available salty clay and the organic material that are available in their locality. Based on the discussion held with the potter community, the people who use these devices, and I have also gone through some of the studies, all they reported that the traditional culture and influences are the responsible reason for age-old sustenance of these devices in this region. And then again, I planned an experimental setup for identification of cooling strength and microstructural properties of these two types of the pot. And you will be happy to know that the pots of off-white color water pots, they have got a good cooling and strength capacity over red color pots. That is why the region, in addition to the cultural traditional aspects, it can be said that these are some of the technical advantages which are responsible for sustenance of this pot in the society, because we are living in the age of science and technology. We believe on investigation, we believe on innovations, and that is why the reason I have conducted all these studies. Further, you can see that there are compressive strength result plot, and in which the samples were cut down from bottom to top at considering height of 50 centimeter for both the plots. And the off-white color water pot compressive strength, you can see it is placed on the top, while the figure at the top side, it has internal and external topology of off-white color water pots. And these off-white color water is basically because of the salty water present in the Rajasthan state, in the area where Western Rajasthan community is there. And because of presence of salt, according to the discussion held with the potter community, because of the presence of salt in the clay as well as in the water, this off-white color is obtained, as well as this presence of salt in the clay. They got very good strength as well as it also helped in the proper centering of these materials. So all this discussion that I am doing for case number 1 and case number 2, they said that how much knowledge on material, how much knowledge on traditional practices our uh, our people from rural community or our ancestors have. And if we could utilize their knowledge there and we could sit together as I have done in my case, then definitely the solutions like G filter, clay ceramic water filter, or many people are working in this area, and they are coming up with a new solution with the help of local people. And therefore I have also done in the same manner. And now let us see the scenario, because this topic is related to water quality. So let us see the scenario of availability of water in the rural area. You people will agree with me here that women in the family, and especially in the rural area, is mostly responsible for fetching drinking water, arranging drinking water, cooling water for cooking, sanitation, and other purposes for her family. And sometimes it is a situation she has to stand in line, wait for her number for water. She has to sometimes walk for more than 5.5 kilometer 5 kilometer too, and sometimes she has to pay money for it to secure the water quality. And according to the table that is presented on the slide, where I have mentioned average time taken in day by day household members to fetch drinking water from outside to their premises. Major states like Madhya Pradesh, Rajasthan, Jharkhand, these are some of the states which are in the position of top 10, where there is a least accessibility of water to the population over here. Sometimes the people have to wait or for 40 minutes to 20 minutes they have to work for fetching a quality drinking water for their household. And not only we are stopping this, when if there is a limited resource of water is available in the country, at the same time water pollution is again a very big issue. Metallic contamination, already Professor Moni has given so many data, so many information on water pollution, but you can see that because of the industrialization, because of many other issues, we have the presence of metallic contaminants in almost all the states of India. And you can see, according to the National Survey Report of 2011, Government of India, New Delhi, there are many villages, like for example in Rajasthan, out of 33 districts of Rajasthan, 32 districts including 41,000 approximately 41,000 of villages are without sterile drinking water facility is present. And in addition to this, some of the study that I have carried out that have reported that it is very dangerous situation for water quality, especially in Western Rajasthan, where we have some people have detected the farrago of bacteria, fungi, and other biological contaminants in local drinking water resources. And according to WHO, globally there are nearly 1.7 billion of cases of childhood where diarrheal cases are there, and that these diseases are especially caused happen in case of the kids less than 5 years old. And therefore it is required to have a significant solution on the prevention of these diarrheal diseases, especially to save their livelihood and especially to save the kids and to save the time and money of the women in the society. And moving further, I just don't want to speak from the aspect that is written in the book. I'm just showing you some of the results that I have tested for one of my project going in a village near Jodhpur, near Jaipur city, where I have collected samples from the one of the village. And the samples were collected from hand pump, well water, and rainwater, which was the primary source of drinking of the community over there. And according to the primary criteria, or you can say the important criteria, there are 15-17 important criteria have been decided by according to IS 10500, which is a standard for rural for a drinking water quality. And you can see I have marked in the red that many parameters you can see over here are uh, not as per the required standard. Even in case of rainwater, the microbial contamination is more than what is required according to the quality standard decided by IS 10500. So this is the situation. It is the data of one of the village where I'm doing one project. So since this is a very serious issue, as Professor Moni has also attested, and looking this particular scenario at very large level, not only me, many government and non-governmental organizations, universities like Shobit University is doing wonderful job in this area, connecting the innovators and rural people for the society, for the cause, for the noble cause of uh, doing this kind of projects in the rural area with the help of AARDO, and industrial experts are also working, and they have developed so many technologies and so many things. Some of the technologies are good for the population of urban area, and some of these technologies are very good for rural area. And these, some of them are presented on the slide also. There is a 3 Cauchy filter. There is a traditional technology of boiling the water for making it for good for drinking purpose. Biosand filter is one of the good solution on rural drinking water. Candle filters, and there are several technologies. This is altogether a separate topic of discussion. Water quality is a completely big topic, and if I start speaking on it, it will consume a lot of time. So let us come back to the context of Western Rajasthan. So when I was looking and studying all this thing, and I found that the clay ceramic water filter proposed by Potter for Peace, that is a non-government organization, they have a solution. They are promoting these clay ceramic water filter, and this clay ceramic water filters are basically have ultra fine pores. You can see in the diagram over here, and because of the high tortuosity present in the clay, that traps the non-soluble and other impurities, including microbial contaminants, while providing a reasonable quality of water and the reasonable flow rate from it. Many researchers have already approved and already studied about the cost and microbial efficiency of these filters, and attested that the frustum shaped clay ceramic water filters are the most effective and long-term water treatment solution, especially for the developing nation. And presently, there are many organizations with the help of various organizations. They are the factory mode of manufacturing of these filters is being carried out, and there is a community services there are people who just do good things for the community. They are distributing these filters for ensuring a quality drinking water in the rural area in Cambodia, in Nigeria, Nepal. There are many organizations doing a wonderful job in the distribution and manufacturing of these filters, but in a factory mode. Now, looking to the perspective of India, and I have already discussed 2 case studies where we found the pottery is a sustainable business, and household inheritance and manufacturing management teaching methods were present in the potter community. They know that how local material can be utilized in an effective manner, and that is why the region now, if we want to ensure the community-based manufacturing of these filters in India, then and again maintaining the good quality standards as the people are already doing at international level. Therefore, it was very much required to understand the pottery process in very much detail, and therefore, because since we wanted, whatever was our thought process was converting an industry operation into household operation. This is a very big job, because in industry the things are moving in a very great manner. The perfect system of raw material extraction, procurement, daily management procedures, efficient learning, teaching and training procedures were applied, and I wanted them to be applied in a household manufacturing system. And therefore, it was very much required to understand the potter community and their practices and their desire to learn about this technology in detail. And therefore, the research team members from our institute, IIT Jodhpur, when I was studying over there with the knowledge on composites and water filtration basics were identified the Potter community, and then a survey that is called a socio-behavioral survey of this community were conducted. And in this socio-behavioral survey, the Potters were asked to provide the answers of several questions considering the criteria like personal information, their desire to learn on the manufacturing technology, their feasibility to manufacture these filters within the household, and the water quality that can be consumed, that the people were consuming in their area, and their practices of pottery regularly the people were doing in this. And you will be happy to know that since the pottery is a community-based profession in the Western Rajasthan, and there are 8 points. There are 8 points we have found and noticed down on which the potter community sustenance is presented. The cultural aspects they have, interdependency on the people in the village and potter community, geological biodiversity, means whatever is available in their area, they just use those things to keep the cost low. Internal knowledge dissemination means member of potter family help each other to make this technology survive, means master potter or the elder potter will teach this knowledge to his family members. Pottery, they do a regular pottery business. They are interested to understand and find the importance of low cost solution so that the people can of rural community or their area can be survived, and they believe in household manufacturing. Water system is also there in some part of India, and therefore on the basis of survey conducted in the Western Rajasthan and some potters of the community from Tindivanam, Tamil Nadu, and some other parts of India. This survey also reveals that the potters were ready to cater the local on reduction of occurrence of waterborne diseases, and since the filter development was also going to create a new window for the rural people as well as for the rural potter community so that their income can be improved, and therefore by some technical aid provided from our team, these 8 points were smoothly shifted into new 8 points: teaching learning principle, direct to cell, trust-based relationship model within the bound of a specific geo-ecological system. It means we did not say that you just adopt our process. When I go and teach this particular thought process to some villages potters, we do not insist that you should just do that what we people are doing. We just try to say that maintain the eco-geological biodiversity system from there. Whatever is available in your system, whatever household things you have in your pottery manufacturing process, you just try to accommodate with this, and then you try to accommodate this particular thing. And that is why I am saying that I have shifted this 8 point into some new 8 points. Now you will now coming to the volume production of G filters from the potter community. We have decided that the volume of product to be manufactured by a particular potters after training or after adoption of this particular technologies completely depends on the trust-based relationship between, as I already said, it is a trust-based relationship. Is complete. Therefore, the volume of the production the people are manufacturing is completely depend on that what it can be consumed by the people in the local community, and further which depends on the quality products the people are going to manufacture. And due to the brittle behavior of clay ceramic water filter according to the material property ceramics have, and it could break in a long distance transport. Therefore, a boundary of cell of this clay ceramic water filter has also been prescribed, assuming this filter metaphor to crops. For example, if you transport some crop from one place to another place, then and if the distance is very long, then it would become less profitable. Sometimes I got call from different people that we want one filter, and their distance is 500 kilometer from Jodhpur, where we have our pottery manufacturing unit, G filter manufacturing unit. So if I transport a filter that costs 350 to 500 rupees to a distance of 500 kilometer, not only it would be not a good decision by from the potter's point of view, but also it is very difficult if it go in the transport, and it could break while we people were sending them. Now, therefore, after the various experimentation, laboratory survey from potter community, survey of first users, experimentation done in the laboratory of Indian Institute of Technology, Jodhpur. As you can see, some of the pictures over there where I'm cutting one pot for getting samples for its strength analysis. There is a furnace we have uh, manufactured in our premises of IIT Jodhpur. I have spent a lot of time with the potter community. Even I have spent some of the night in their home to note down the water temperature profile for their furnaces, and that is how, with all the supports we received from local community, local potters, and several local NGOs, as well as some of the organization, G filter was introduced for the rural societies in India. And basically, this G filter, as Professor Moni has introduced, it is a simple, low-cost household drinking water treatment solution that works on the principle of gravity. This filter consists of two containers. You can see there is an outer container, there is an inner container. Outer container you can see in the inset at the downside, and the up, which is the responsible and which is called as G filter, and it can hold a water up to 9 liter. And when you keep this particular device receptacle in the outer container, either made of steel, plastic, or mud, it is going to give you a filtration rate at least up to 1 liter per hour. And if you fill this particular filter in the night, I'm talking in the aspect of a small family of husband, wife, and a child, then you are going to get 10 liter of water in the morning. And this is how you can continue make a cycle, and you can get the drinking water at very low cost in your locality by the nearby potter. Now, coming to the manufacturing of this clay ceramic water filter, because it is very important when you are in a community manufacturing system, it is very important that we should not change the community manufacturing with 90-degree angle. There must be some technical aid, there must be some very small change in their thought process. Otherwise, it is very difficult for community people to grab that knowledge, and there should not be very much technical details added in their community knowledge. And this is what is maintained while we have disseminated this particular knowledge within the community of Western Rajasthan. So you can see the steps, various steps of manufacturing of clay ceramic water filter with the facility available at the potter's house. You can see the first step is raw material preparation. And since I have already said that pottery is the profession where all the family members work together to get job done, right? Everybody has some responsibility, and that is why the reason I have already suggested that when survey we have planned, according to that survey also revealed that the pottery is a mirror of best industrial practices that is there in any industry. And in preparation, there is a first process called soil ramming, where the soil is converted, or mined soil from the raw soil is converted into small powders of range 0.18 to 3 mm, and then sieved by sieve size 3:3 mm. And at the same time, the saw is also sieved with the same sieve which is being used for sieving this clay. And women potters in the family is responsible for doing that particular job. And then traditionally, equal volumes of soil and organic matter, that is again come from the concept of Santi community women practice. Because if you have noticed earlier part of this presentation, there it got a very good strength because of 50-50% volumetric ratio, and therefore we tried with the same. And once the 50-50% volumetric ratio of clay and sawdust is mixed together and mix it properly, 70% volume of water is added slowly to make and form a disc shape of composite that you can see at the bottom, at the last figure in the corner. These composites or disc shape of composite that you can see in the figure is then kept overnight under a cover of moist glass. And later, so up to here, before proceed up to here, the process is same. The pottery process is same. What potters are generally using in making other pottery products in their household. Now here the aid, or here some additional information or technical aid from the research point of view has come into the picture, where in order to prepare the frustum shapes greenware, we have developed a simple press that works on the on a jack, and it has a male female you can say aluminum molds, and when you compress the green composite that is manufactured in the previous stage and press it properly, then you are going to have a greenware as an end result. Now, and I'm happy to inform you that this press was also locally developed and now manufactured by one of our helper in Jodhpur city. So the potters who want to purchase this particular machine or get into training of this, they require to have this machinery, or that is why the reason I'm saying it is a technical aid. Here, this particular process is different process other than pottery people were doing, and I'm just supporting the people, and my master people potters are also supporting in how to operate this particular press. And our helper, as I said, Mr. Ankush Sharma from Jodhpur, is responsible for supplying this filter, manufacturing this filter press within the community of potters throughout the India. And the greenware which we have formed in this case is 23 centimeter high, and it has a base diameter of 25.5 centimeter. And these dimensions are set according to the commercially available buckets in the market, because this greenware has to put in somewhere, and that is why the reason these dimensions have been decided on the basis of commercially plastic bucket available in the market. And some other devices are also required, like greenware separator, and that is how once this greenware is prepared using this press, we have to keep these greenwares in open environment for 2 to 3 days, and then baking is performed. Now baking is again very important aspect and very important thing in the manufacturing of G filter, because traditional baking in updraft furnace is performed. Here the process is different from the factory mode of baking of these filters practiced around the world. And following the traditional practice of potter community in Western Rajasthan, where they use the method of off-draft baking of their flour base, right? Because they manufacture different products, and different products have different baking process. So experimentation details and the technical studies that have done finalize that the baking process that potters use for baking their flour base is good baking techniques. And in this baking technique, the greenwares are kept in inverted position 1 to 2 feet above from the ground, and local materials are used to bake these filters. And you can see that the temperature profile and time that is required to bake these filters are at covering the temperature approximately 900 degree centigrade, and a temperature range from 150 minutes to 250 minutes, that is approximately 2 hours is required to bake these filters. So once these filters are baked using this local traditional baking process, these filters are kept as it is in the furnace, and next day we potters can retrieve this clay ceramic water filter, and after baking it properly, we people or anyone can use this filter for drinking or for cooling for its regular use. Right. Now coming to some of the technical properties that I should discuss is the first property is pore orientation and pore size of these filter. And if you can see that the pore size of these filters we have measured, or some studies have decided as a standard, is approximately 0.2 microns. And since pore orientation is very important aspects to ensure good filtration and proper filtration and proper flow rate, and that is why the reason it has been also identified that when you use 50% volumetric ratio, the pore angle orientation is approximately 90 degree in this case of clay ceramic water filter, and that is good according to the international standards. Now coming to the water filtration rate from these filters, you can see that we have conducted an experiment with 4 sets of the filters for a long period of time. And when you fill these filters in the way the pictures are are showing to you, you can see that the filters may attain a filtration rate of 900 ml per liter when it is operated under fully filled condition. Here I would like to inform you, the users of this G filter, that you should not start using G filter on day 1 of purchasing. For example, when we purchase pot in our regular mode, what we do not use pot. Maybe it is not the case of your area, but in our area it is a case. When we purchase pot, we do not use the pot for day 1. We just fill the pot, and later from day 1 or from next day we start using that pot. That's the same thought process has been maintained in using this G filter, and we advise the people that you should not use the G filter for in day 1, and later after day 1 or day 2 you start using these filters. So as you can say, following the Darcy's formula and from the pores that is generated because of 50-50 volumetric ratio and presence of the small pores in the range of 0.2 microns are responsible for giving a good filtration rate, approximately 900 ml per liter according to the test reports when it is operated under fully filled conditions. The best quality water quality test, the best part of this particular filter is that it is very good in filtering the turbidity or clearing the turbidity according to the test result that we have got by National Test House, Jaipur. Actually, we have gone through the complete 65 parameter testing from this G filter, and TDS, salt, and other parameters are found. 50% means 50% reduction of these parameters can be obtained from these particular filters as per the test report by National Test House, Jaipur, and according to the test that we have conducted in our laboratory at IIT Jodhpur. As far as the microbial filtration efficiency is concerned, a team of BTB project of final students of IIT Jodhpur helped me in this way, and they have performed the experimentation on the microbial filtration. It is a very long step and 1 week procedure. I don't want to discuss it much in detail. And you can see that when the after dilution and the colony count of the microbial growth or microbial colony growth, it is found that up to the log reduction value of 1.7 to 2.5 can be obtained from the filtered water from the G filter. And if I talk in terms of efficiency, this has the efficiency of 99% according to the test that we have conducted in the laboratory. And up to here, it is very clear that how G filter can be manufactured from the local traditional manufacturing units by just adding some technical aid and getting a machinery from the local manufacturer at Jodhpur. And that is why the reason we were satisfied and got satisfactory results on the experimental and the various survey from the first users of this community. The first workshop for 50 potters of Jodhpur district, or you can say Western Rajasthan, is conducted at Arna Jharna Museum located at Jodhpur. And we got tremendous knowledge and good response from the potters. And at the same time, with the support of some government organization, we have distributed at least 5 machines to the potter community, because the cost of machine is somewhat high, because of the limited manufacturing. If the manufacturing of these machines are increased in number, then definitely the cost will go down, and therefore it is difficult for a potter to get this machinery at his own. And to support them, we have initially provided 5 machineries in the different potter community, and we have trained in such a way that those people could become the master potter, and they could provide the training on our behalf. Because I just could talk about this technology. If you say just go and manufacture this filter with the potters, no, I cannot manufacture it. I can just talk about this technology, but we have created the master potters. We have provided the information, and we have done so much work with the potters that now my potter become a master potter, and we have identified a team of master potters in Rajasthan, in Madhya Pradesh, in Bihar, and in Tamil Nadu, so that as and when the technical team and technical training is required, they people go. And therefore, one by one, we have conducted the workshop in Rajasthan. We have conducted the workshops in Kerala, Tamil Nadu, and Bihar for the potter community, and some of them are working very effectively. And you can see the manufacturing process. After manufacturing, the proper packing and proper delivering to the nearby customers is very, very important. And therefore, my master potter, whose name is Abdul, and this is the pictures of the open lab, or you can say the open field laboratory of our workshop and training unit at Banad village in Jodhpur districts of Rajasthan, where he is doing not only manufacturing the outer container, he is also manufacturing the pots at regular interval, and as and when the demand come from the local community or some people, we supply this filter in the nearby community, not at very long distance presently. So you can see, as a part of fieldwork, product development, and technology transfers, we have already provided training to various potter communities of Tamil Nadu. You can see my master potter, Mr. Farooq, is giving training to the potter community of Tamil Nadu, which was supported by Emeritus IIT Madras. Again, Tamil Nadu potters are there. There are some potters of Bihar and Kerala who where I have also visited to provide. Basically, what we do, either we invite the potters to our place to get training at Jodhpur, or if some funding support is provided from some of the organization, we go to some of the places in across the India with our machinery and provide basic training to the potter community, as happens in case of Tamil Nadu potters, where we have provided the training to the potters over there in the Tindivanam village near Tamil Nadu with the help of Emeritus team of IIT Madras. At the same time, not only providing training, I just keep on walking across the India to speak on this particular topic. As I am speaking today, I have given presentations, I have took part in various conferences and the workshop like at NIRD, very good platforms like NIRD, CSIR, the IIT, various IITs, and some government and non-governmental platforms. And today it's my pleasure that I am delivering this talk at very good university, that is Shobit University, and I'm really happy to be associated with the Professor Moni and all other the team members of this university who are conducting and doing a wonderful job for the development of people in the rural area. Inspiring the works and the talk that I have delivered at so many places, many people to support me are visiting my places at regular interval. You can see in the figure, Mr. Lalit Sharma from Saigal Foundation once visited at our place, and later he contributed for sending 6 potters and a team to the Jodhpur by his organization and got basic training. Later, as expansion to this project, our master potters and team member went to Samastipur to support the potters of there to manufacture the updraft furnace and provide the necessary additional training to the potters. And it is very important to note down that now though those potters are sustainable, and they are manufacturing these units in Samastipur districts. We have also got a great visit of the members from Potter for Peace, Mr. Don Hall and Jennifer Melly. We have similarly got the good presence of the executives from Samagra Foundation and many other organizations too. I keep on walking towards the Potter community. Not only just I'm talking and going to the big platforms. I just keep on visiting various villages also, while when there is a distribution program, when there is a initial training is required to be given to the first users of this clay ceramic water filter. And these figures are these pictures which are presented on the slide are the pictures of our recent project. I am just carried out with the help of Water Harvest, which is doing a very wonderful job in harvesting the water and creating the tanks for the rural societies in Rajasthan. So initially we have chosen one village where 50 filters were provided and basic training of was provided to the users. And on the basis of the feedback that potters are going to give, the project was started in the month of December only. And on the basis of feedback provided by these filters, we are going to continue this project with the help of Water Harvest UK in the Rajasthan. And that is how up to this discussion, you people are clear that this clay ceramic water filter manufacturing is not only extended and not only just cover the G filter manufacturing in our unit, but also conduct various workshops and involved in distribution. And one of my colleagues have established one of the entrepreneur business in this technology. I have filed the patents. My professor is again doing research for the subsurface irrigation of this technology, and many people are interacting us for collaborating in expansion of this terminology for the benefit of the society and to ensure quality drinking water in the rural area. And presently, if I say my particular thought process and objective to ensure the strengthen the potter, ensure the quality drinking water in the rural societies so that the potter can become one-stop solution for rural drinking water in their villages. In India, in India, if you see that at least one potter family we have in our village. So if I could provide training to all the potters in some support from government organizations, some support from the university like Sobit University, then definitely I would be able to teach all these potters so that the traditional knowledge and traditional learnings from these communities can be preserved for a long time. And we just want to give this technology to the potters community because we want to survive the potters. I have got so many knowledge and very good information from the potters. That's why I'm very much connected with the potter community, and that is why the reason we just want to give this particular technology to the potter communities. And it is very important to ensure that the people of bottom of the economic period are also equally required to get safe and clean drinking, low-cost drinking water solutions within their household. And only this community, only the potter community, only sustainable solutions like G filter can provide the solution on saving the rural economy, on saving the jobs of the potter community. And at the last, I would just like to highlight that some of the papers you can read to get more detail about this technology. You can read my PhD thesis of my colleague Dr. Amrita, who has done wonderful work for the filtration capacity of this G filter for arsenic removal. And there are so many print media and social media platform covered our story, and you can read and get the knowledge of these filters. These are some of the supporting organization I would like to thank, which is not only given motivational support, financial support, but they are continuously helping me towards the development of these filters. And because of their support, because of their motivation, I could be able to establish these filter projects in Rajasthan, Chhattisgarh, Tamil Nadu, Bihar, and Kerala. Now, question arises: if we want to establish G filter, then what is the requirement? The requirement is you have to find a potter community within your household. and you have to just make sure that if he could buy the machine from us, he could get free training from us, either inviting me to their place or providing or sending the potters to our place to get free training. And since the potter will require your help to get the machine, so some additional support will be required from you. So I am just thankful to Water Harvest, Enacted IIT Madras, Segal Foundation, Enactors, who are doing a wonderful job, especially my institute, Poornima College of Engineering. And because of that, research team members from different locations are now located in Maharashtra, Bihar, Madhya Pradesh, Chhattisgarh, even in Tamil Nadu and Kerala, that can help you to establish G filter or clay ceramic water filter management program in your organization, in your locality. And these are the some of the awards, some of the cognitions, some of the felicitation that I have received when I provided this particular technology to the potter community across the India. It is not, I'm and when I presented this particular technology at IIT Jodhpur, I met central minister over there. I get an opportunity to meet wonderful personalities, and they all promised me and helped me in a great manner. With this, I would like to stop here, and I'm thankful to entire organization of Shobit University, Honorable Chancellor of this university, the team members, and the audience who is watching us and continuously on this platform, and just listening my words, what exactly I'm saying about G filters. Thank you again. Thank you so much.
Thank you very much, Dr. Rajkumar SATANKAR, for your wonderful talk, very meaningful talk, and how the potters community of a village has to be helped, strengthened through technology innovation by institutions like IIT Jodhpur, and also your present institution and your continuous research in this area. And you are able to give a complete value chain in this aspect from a local environment, a local culture, and which is being traditionally operated, and also how the technology adoptions and how to make it as a community-based manufacturing enterprises. I'm very happy that I was able to network with you through Mr. Senthil Kumar of Dr. Arunachalam Trust. He has talked to me, and he has given your coordinates, and that's how I was able to network with you to request you to deliver a talk in this very important webinar series. And today you have fulfilled that objective of bringing in your research-based technology innovation and application. G-Filter, the simple low-cost solutions to drinking water treatment in rural India. We have been from the university, Shobit University, and from the centers of excellence. We have been working and have been inviting a lot of research scholars as to how to build in health informatics network value chain, One Health, Eco Health. Today is the World Environment Day, and today is your talk, and our mission of how to bring in health informatics value chain in this country, integrating human health, plant health, animal health, fish health, water health, and soil health, and air health. And water is an important ingredient, and that is an area where, for solving the drinking water problems, pollution in rural India, you have brought out a very important technologically enabled equipment with the help of local potter community who has traditional knowledge for centuries together, artisans. It is very important And it is this type of technology innovation has to be supported, promoted in a very sustainable manner. India has been traditionally known for sustainable lifestyle and sustainable development, and that's why our honorable Prime Minister said it, that we should be vocal for local and make it global. And this can have a sustainable production and also customizable and constructive community based manufacturing enterprises in the era of globalization. So as I said it in my introductory remarks and presentation, that as also it has been talked and promoted by Dr. Jabamali Vinanchi Arachi in his talk, that seizing the opportunities for for open innovation and value creation networks in the digitalized world for self-reliant economy. And that's why I said it, that in the era of internet and with the industry 4.0 technology applications, like technology like 3D printing can facilitate your innovative research and applications, and technology can be transmitted to the pottery community located throughout India and also neighboring countries like Africa, Asian countries, through 3D printing technology. So this is very important, and we are very happy that we are able to have you in our international webinar series on open source digital technology towards a self-reliant India, Atmanirbhar Bharat, on the topic G-Filter, the simple low-cost solutions to the drinking water treatment in rural India, on the day of World Environment Day, 5th June 2021. With this, on behalf of the Honorable Chancellor of Soviet University, His Excellency, the Secretary General Ardo, and on my behalf, I would like to thank you for your wonderful presentation, and we would like to have you to get associated with these two centers of excellence to motivate and promote our local community who has traditional knowledges, and how to convert their knowledges into scientific communication and bring under IPR, so that this traditional community can have some sort of a return on investment on their knowledge which they are possessing and preserving, and having a cultured value on that, their traditional knowledge over centuries together. Thank you very much. With this, we would like to thank all the participants of both in India and abroad, and also would like to communicate for more research inquiries. Please contact Professor Moni Madaswamy, Professor Emeritus and Chairman, Center for Industry, Informatics Development Solutions and Application, and Center for Industry 4.0 Studies, Technology Studies and Applications, and former Director General, National Informatics Center, Government of India, New Delhi. My email address is moni@sovietuniversity.ac.in. Thank you very much. With this, we will close the webinar and we'll leave studio. Thank you.